Microsoft ignites a copilot explosion, while Google generates magical music. Meanwhile, Meta gets it all on video, and OpenAI gets the award. We will explore all of this and more on today's The Great Indoors. Microsoft held their Ignite conference this week in Seattle, and it included a whole bunch of announcements that ranged from software to hardware and everything in between. One of the things they announced was new hardware, and specifically 2 chips. The first was the Azure Maya chip, which is meant to be used to train and run AI models. The other was Azure Cobalt, which is meant for more general purpose workloads. Now, the reason I thought this was interesting is this is why the exponential growth of technology is a thing. And it points to the cyclical nature and the feedback loop that technology has with itself. You know, we started leveraging the most powerful GPUs that we've ever created. This includes NVIDIA GPUs, the A100s, the H100s, now H200s, and more. The most powerful computational ability that the human race currently possesses. And we take all of this and we create what in the future we're going to look back at as a baby AI, right? It's the first real AI that the human race has produced. But even in its infancy is an incredibly powerful and capable AI model. All of the frontier models are. And it makes absolute sense to take the cognitive enhancing capabilities that these models possess and leveraging them to create better GPUs and better chips in general. Creating chips and the lithography techniques that we employ today is some of the most advanced and incredible technology the human race has ever produced. If you have the chance, I highly recommend seeking out videos and walkthroughs on what that process looks like. It's mind-blowing. And it really kind of pushes the cognitive limits of the human species to create these things. And so having the enhancing capabilities of the frontier AI models to help us design and produce better chips is an incredible thing to be able to do. I am really excited for what the next generation of chips is going to look like, because I think they're going to help us produce even more amazing models. But get ready for things like this to completely change the industry. The other major announcements that Microsoft had was bringing Copilot to every single product that they have. Like, they were not kidding when they said that they were going all in on AI. They brought Copilot to Microsoft 365, Copilot Studio, Copilot for Service, Copilot for Azure, Copilot in Microsoft Dynamics 365 Guides. They even renamed Bing Chat to Copilot. I'm surprised they didn't announce Copilot for Copilot. Not to be outdone by other companies with similar promises like OpenAI, Microsoft announced that more customers could be defended for any adverse judgments that were made if they were sued for copyright infringement as a result from the outputs generated by the Azure AI service. Not all the Azure AI services, but still, this is a pretty remarkable thing for companies to start doing. And we talked last week about how OpenAI was announcing a similar system. But even beyond AI, companies like Elon Musk's X platform have announced coming to the defense of their users if they were being sued for free speech. It's an interesting trend I'm starting to see in corporations coming to the defense of their users. And the last thing I'll talk about is the Azure AI text-to-speech avatars, which can be used for content generation. My understanding is that it allows the user to do text-to-speech to have the avatar say what you want them to say. Let's see if we can check this out.
Let me show you how to create an engaging avatar video in 4 steps. It begins with a talking script for your avatar.
I gotta say, the avatar is a little bit early stages.
However, we recommend to use the Speech Synthesis Markup Language, SSML, for advanced requirements.
So one thing that's not clear to me is whether the user provides the image that the avatar will be based upon. Now, the one thing you can do is control what the avatar does, including pointing to things, what the avatar says, how they can pronounce certain words, and gives the user a lot of control in how to leverage this. It doesn't look like there's a live demo yet, but I'll be keeping an eye out for that. Sam Altman accepted the Hawking Fellowship Award on behalf of the entire OpenAI team last week at Cambridge. His acceptance included a few brief remarks that he made to the gathered crowd, but was mostly a Q&A session between the members of the audience and Sam. And there were a few bits in this that I thought were really interesting. I wanted to share them with you. One particularly passionate comment he received from an audience member was related to social media. Now, it's no secret that social media as a whole has had a lot of negative impacts on society. There have been studies done in regards to this, and it's responsible for an immensely negative impact, in particular with regards to young people. But Sam voiced comments that he described as a little bit contrarian, that he feels that social media has had a net positive impact on the world. And indeed, any one of us can think of something positive that social media brings into our lives, but recognized that there were these immensely negative impacts that it's had, and that he felt that the previous generation of tech founders got a lot of things wrong in the deployment of social media. And not only that, but institutions and government failed in their responsibility to defend society against those negative impacts and to mitigate that harm. And he talked a lot about the incentives of corporations and how a lot of times those incentives can be rather screwed up. They can run quite counter to the benefit of entire groups. And he pointed out that he didn't feel that these people were particularly bad who deployed these things, but oftentimes very good people are put into systems with very bad incentives. Probably many of us have seen that in action in our own worlds and our own lives. But the one thing that's very important to do is to learn from the lessons of the past. And this is something that OpenAI at large have taken to heart. Their entire approach to AI has been to release early, release often, bring this incredibly disruptive technology to the world in its early stages, and give the world time to figure out how to deal with it, to make mistakes with it, at a point where the technology isn't powerful enough to cause drastic harm. And then figure out what the lessons are to learn from that and bring those lessons forward as more and more powerful technologies are released. I mean, we've all learned that mistakes are great things. They're opportunities to learn. And that is nowhere more important than in really powerful technologies like AI. He also made a comment about really powerful AI, and in particular AGI. Now, he seemed to feel that we're not at a place where we have AGI, though he did note that if you ask someone from maybe 10 years ago and describe what technologies we have now and what the AI was capable of, that they would probably say, yeah, that sounds like AGI to me. But I think any of us using the technology now would say, no, we're not quite there yet. But we are close enough now that the definition of AGI really matters. But this conversation did happen before Google released their levels of AGI papers. So we know that we now have a first cut at trying to define what AGI is. Another question from the audience was, how can a young person growing up in a world with AI and soon AGI prepare themselves to live in that world. And Sam's response, I thought, was very interesting because really it was no different than what a young person should be doing in a world before AI. And the question was couched in the context of the massive impact AI has had on the education system. They've been struggling to figure out how to move forward in a world where kids have access to incredibly powerful technologies. But Sam pointed out that while it's important to learn specific domains of knowledge when you're in school. We all have our majors that we commit to when we go to school, but the real value of education comes from not learning those particular domains of knowledge, but learning how to learn. And I think that was an important thing to point out because it has been well discussed how disruptive AI is going to be. And yes, a lot of jobs will probably go away, and the people in those jobs will need to adapt and shift and pivot to other things. And you can't do that easily unless you are really good at learning how to learn. I think it's also well discussed that AI is bringing us into a world where things are going to be changing at a breathtaking pace. And the number one ability a person can have in this world is an ability to adapt, an ability to learn. And that's the value of higher education. I was also interested in hearing that he felt that like every previous disruptive technology that the education system has had to deal with, right? Calculators, Google, and now large language models, that there's always this sort of knee-jerk phase to it, right? Banning calculators, banning the use of Google, that at some point educators adapt to the new tool. And he felt that educators have moved past the knee-jerk phase and are now working with the technology. And I've seen that myself with my own educator friends who have been working with language models in amazing ways for their classrooms. And it's been absolutely incredible to watch all of the creativity that educators employ in their classroom. Go thank your educator. It was also interesting to note that Sam Altman said that making life better for people is a moral obligation, and that the only way to do that is through technology. A lot of people will probably push back against that and say, no, technology is not the only way to make life better. But I think when it comes to solving the world's most difficult challenges, climate change, feeding the world, energy, yeah, technology really is the only way to do that. So while your point is well taken, there are lots of ways to make life better. Technology is the only way to solve the really big problems. And the last thing I'll point out is Sam Altman seemed to feel that the British people are quite reasonable. Yes, I do think the British people are quite reasonable. Quite right. Quite right. Now, I probably don't talk about these kinds of things enough, but I was really excited to see that Google DeepMind has announced a new model called Lyria. Now, Lyria is capable of doing text-to-music generation, and DeepMind has partnered with YouTube to create some compelling demonstrations of this technology. The first was creating music generation tools that allows an artist to do things like hum a tune and record the tune, and then use the model to recreate that tune in a variety of instruments, whether it's saxophone, piano, you name it. I wonder what would happen if you hum a tune and then converted it to drums. Da 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 da. Boom, 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 boom. Tss. Of course, some of y'all don't need drums. But the other technology they announced was something called Dream Track. Now, this was really interesting. They made a deal with a series of 9 artists, from Charlie Puth to T-Pain, who all signed up for this project and allowed the team to recreate their voices in the model. So then you as a user only have to input a prompt or even a set of lyrics, and the model will generate a song by that artist according to your prompt. The songs are a maximum of 30 seconds long, and my understanding is that the artists can have any song they don't like taken down. And it does sort of raise the question, like, what happens if the next big hit by one of these artists is not by the artist? Who owns that creative work? Now, I'm sure in this instance, all of that legal paperwork has been figured out. But it does point to the fact that we're about to live in a world where models that are freely available to anyone have the capability of doing this. This is, of course, something that the entertainment industry has been contending with these past few months. The writers' strike, the SAG-AFTRA strike have all been trying to contend with how can artists protect themselves in a world where they can be copied. This is an issue that I am caught weirdly in the middle of. Now, I haven't talked about myself very much on this show, and probably will a little bit later, but it just so happens that I spent a decade in the film industry and now a decade as a computer scientist. So I feel weirdly in the middle of all of this. And on the one side, I absolutely sympathize with all of the artists who are struggling with this. I mean, it is already hard enough to be an artist in the world. The economic incentives often run against you. But now when you're in a world where somebody can come along, take everything that you put out there previously, not knowing that this technology was coming, use it to train a model that can produce anything that you could, and then go and use that absolutely for free. What do you do? And then, of course, the technology side of me is like, God, AI is so cool. So I get it. But of course, we have to balance that excitement. We have to temper that excitement with a consideration of the artists in our lives who work so hard to bring us joy and entertainment and enrich our lives with everything that they do. And clearly, I am going to have a more in-depth episode about this in the future. But this tech is absolutely amazing. I don't have access to the demos just yet, but you can bet that when I do, you'll be like the second, third, fourth, however many of you are there to know. But speaking of amazing new technology for the entertainment industry, Meta recently announced emu-video, which is a text-to-video engine that allows you to input a prompt and generate a short-form video from that prompt in a variety of styles. Now, the way this works is in two stages. The first is the model creates an image based on your prompt. And then in stage 2, it uses both the created image and your prompt to generate a short video. Now, the video is only about 4 seconds long. It's about 512 pixels and runs at 16 frames per second, about half the speed of normal video on the internet. But the benefit from doing this in 2 stages is that it is incredibly efficient at generating these videos, and it's a very promising start. And this also means that theoretically you can just hand it an image that you already have along with a prompt and bring that image to life in incredibly creative ways. I can easily see users giving it photos of loved ones that they can't see anymore. And there's a lot of implications around a technology like that that make all of this very, very complicated. They present a demo, which in my mind was not really a demo, because what it is an interface that allows you to select from pre-canned options that in combination will generate an image. The number of options it provides results in a possible of 900 different outputs, which I'm pretty sure have all been pre-rendered because below they allow you to search through the database and it's the exact same images that are possible to create above. But really, that's not a demo. That's an example with style, but it is, nevertheless, an amazing technology, and I look forward to being able to try it for real. So now I want to do a new segment that I am calling the Preprint Paper Parade, where we analyze the abstracts of AI advancements and add an ample amount of attitude around their audacious ambitions and astounding applications. What can I say? I like alliteration. So now that GPT-4 and other models have access to internet search, I thought it would be interesting to ask what were the AI paper preprints that were generated this week and what it thought the top 10 papers were. Now, as a reminder, a preprint paper is a paper that has not been peer reviewed yet. It's an early release of recent work in AI that the authors are sharing with the world before it has been properly peer reviewed, but is nevertheless an interesting peek into the work that people are doing. So this is the list of papers that GPT-4 gave me, and I picked out a couple that I thought were interesting. Although I will point out that the last paper it gave me was partial stabilization of an orbiting satellite model with a flexible attachment. Yeah. That's not AI, but thanks for playing. But one paper it gave to me was from the Gaoling School of Artificial Intelligence in China called Are We Falling in a Middle Intelligence Trap? An Analysis and Mitigation of the Reversal Curse. Now, full disclosure, I have not had time to read these papers in full, only the abstracts. But the reason this jumped out as something I think I'd be interested in reading is because it talks about the order in which models learn from the data, and how if you reverse the order that you present that data, that it can dramatically impact the model. Now, if you consider the fact that large language models are built using artificial neural networks, and artificial neural networks are themselves modeled on the human brain, and all of us with actual human brains learn in a highly serialized temporal manner, and the fact that the order that we learn things in dramatically impacts how we use that information, then it's no surprise that it impacts the model as well. And to illustrate my point here, imagine when you learned the ABCs. All of us learned the ABC song as a handy way of learning that entire string of letters, which is a lot to learn. But when you're younger in particular, and admit it, this is also true for some of us adults, if someone asked you what letter comes after, I don't know, pick one, M, that in their brains, that child is probably going H-I-J-K-L-M-N. N is it. It's N. Because you have to go through the sequence of letters in a serialized fashion to get to the answer that you're looking for, because we learned that in a sequential manner. And that's the way that data was presented to us. Now consider someone asking you to say the alphabet backwards. You probably can't do that with any degree of ease, because that's not how you learned it. You learned it in a specific order, in a specific sequence. And that's just one example of why the order of information matters, even to a language model. So it's interesting to me that they're coming up with ways to mitigate that. A popular example they give is in the training data for language models, it very often encounters the phrase Steve Jobs and Stephen Wozniak founded Apple Computers. And so if you ask a model, hey, what company did Steve Jobs and Stephen Wozniak found? It will very reliably say Apple Computer. But when you ask a model, hey, who founded Apple Computer? It has a much more difficult time connecting that back to Steve Jobs and Stephen Wozniak, because it learned that data in a particular order. But they're trying to come up with a system that allows a bidirectional association between these two concepts that can help mitigate that problem. It's just an example of one of the things that they're doing to improve large language model capabilities. The other paper I thought was interesting comes out of Tencent Labs in Seattle. You have a typo on your paper, Tencent. Anyway, chain of note, enhancing robustness in retrieval augmented language models. Now, why did I pick this one out? Well, first of all, chain of noting just by title is very reminiscent of chain of thought, which is a very useful prompting technique when working with large language models. As a brief aside, I was speaking to a friend of mine who is in no way an AI researcher. In fact, he's a writer and playwright and does not really work with language models. And one of the things he mentioned to me was how difficult it can be to work with models and how can you improve the results you get from one of those. Should he pay that individual that's offering to give him magical prompts to improve his outputs? And my answer to that is typically no. That information is typically out there and available to you, and you really don't need to pay people for that. And now that he's told me that, it's something that I'll be talking about on this show soon. But back to this. We all know that models have a problem with hallucination, which is this notion of very confidently presenting information that is absolutely incorrect as though it were a hard, cold fact. And this technique tries to get the model to reduce the amount of hallucinations it does, or at the very least to say, I don't know, if it indeed does not know. But it does this by trying to improve the retrieval and evaluation of the resources available to it so that when it does go try looking for an answer, it can present the most optimal answer, or if it fails to find one, says, But I can pretty much guarantee you that the number one thing that labs around the world are working on right now are how to mitigate the hallucination problem. It is the number one thing standing in the way of taking over a lot of cognitive work from a lot of people. But again, I have not read these papers in full. GPT-4 presented a list to me, and these are the ones I thought were interesting based on their abstracts. And as always, preprints have not been peer-reviewed, and that should be kept in mind. Okay, that was all the news that we have this week. So now I want to take a moment. Now that I'm 5 episodes into this show, I've come to the decision that now is the time I'll finally introduce myself. Because I realized that I just sort of dropped in and started talking about AI and other technology to you, and never even introduced myself. So pull up a coffee with me. Let's chat. Hi, I'm Chris. I'm a computer scientist, and I've been one for just about a decade now. I specialize in something called modeling and simulation. That's where you take a concept from the real world, you try to model that in a computer, and then you can run simulations against that thing to try to ask questions like, what happens if I do this with it? Or for some people, that means what happens if this thing blows up? Or for others, it's what happens if you run this thing into a wall? Some people want to know what happens when it's left out in the weather for too long. There's all kinds of things you can do with modeling and simulation. Computers can be insanely good at modeling things. In fact, one of the things I didn't talk about today was a recent announcement from Google, who recently released a new system that models the weather way more accurately in some respects than anything we've had before. That's pretty darn cool, and typically takes an insane amount of computation to pull off, though I think their model does it with way less computation. But without getting too much into the weeds of the type that I do, I'll just leave it pretty high level and say I do modeling and simulation. But I haven't always been a computer scientist. Before I did that, I was actually in the film industry for like a decade. I spent 5 years working behind the camera on productions ranging anywhere from huge Hollywood blockbuster movies to commercials and everything in between. And then I spent 5 years working in front of the camera. One thing to know about me is that I have a twin brother, and he and I had a lot of fun doing roles as twins over the years. And we were in movies like Pirates of the Caribbean 2 and 3, and I'll probably link some of that work below. So how did I go from working in the film industry to working as a computer scientist? Well, you see, I wanted to... Okay, that's a long story. Suffice it to say, I discovered programming somewhere along the way, and I fell in love with it so much that I finally decided to go back to school and get a master's in computer science. And that was all well and good, and I've been having a great time doing modeling and simulation ever since. But then something happened at the beginning of this year that changed everything for me. I had heard about these amazing new tools for software developers because that's a really big part of my job. Tools like ChatGPT and GitHub's copilot tools that were absolutely mind-blowing. So like any good developer, I went and I checked those tools out. And what I discovered there knocked my socks off. That inspired me to look more deeply into the world of artificial intelligence. So I sought out all of the companies and all of the researchers who were pushing on the frontier of that work. And when I started to follow what they were doing, what they were talking about, the papers they were putting out, I'm not going to lie, it actually freaked me out. We've touched a little bit on things like the alignment problem, and all of us have heard Sam Altman and others talk about the potential dangers of artificial intelligence, but back then, absolutely no one was talking about it. Now, don't get me wrong, there are a lot of amazing channels on YouTube that talk about technology. And now there's even more that talk about AI. But I realized that I sort of sat at the nexus of these two skill sets, the entertainment industry and computer science, and I had a unique perspective that allowed me to talk about technology. And I think the world needs more science communication because things are happening so fast now that I think it's freaking everybody out. And that's why I've started this channel. Because for reasons I'll talk about later, technology is moving at an exponential rate. And humans are not equipped to think in exponential terms. We live in a linear world. It's a well-known issue, and there's been research on this. And so it's very hard for us to really grasp how fast technology is moving. You hear it all the time. People look at models like GPT-4 and say, well, it makes a lot of mistakes. It makes a lot of goofy mistakes. Things that you would not expect a really powerful model to do. And yeah, you're right, it does. But that model is probably going to solve that problem by next month. And in a year from now, the models that we'll have will make this year's models look quaint. And those models are really going to impact the world. It's going to impact the economy, jobs, everything. And we should all endeavor to understand that as best we can now, because it will allow us to better prepare for what's coming. I mean, don't get me wrong, I completely sympathize. You hear about what's developing in the world of AI, and it sounds like science fiction. I remember stepping away from reading the papers that talk about the alignment problem and how AI models of the future, the really super intelligent ones, could cause really catastrophic harm to the human race. And after a couple of days, I would think, nah, that's not going to happen. It's really easy to revert back to our linear world, but we have got to start thinking in exponential terms. We have got to explore all of these things as best we can, no matter how scary it seems. That's why I'm exploring the great indoors, and I'm really glad you're here with me, and I hope you continue to be with me as we explore. I will do my absolute best to find out what's going on, break it down into the really critical bits that are important to know, and cut out the junk, because none of us have time to keep up with these things. Thank you so much for being with me today, and I will see you next time. Ah, it is coffee time. Quite right.